let's start taking a look at this. We have here, there's two different lines in the cafeteria with two different pricing systems, one for nachos and one for sandwiches. And we're going to see if we can write equations for each of those lines. So, what can we do? We want to write an equation for the nacho line and an equation for the sandwich line. So if we think about just the nacho line part, we know it costs $1 to get a bowl of chips, and then $2 for each topping, or $2 per topping. How can I write an equation for that? What do we think? Which of these values changes as we get different types of nachos? The $2 per topping. So a big keyword to watch for on these, per. A lot of times, almost every time, that's going to mean it's going to be multiplied against something. So this is a lot of times going to be something like a slope. So we know the cost for our nachos is going to be, I need to get a bowl and I'm going to fill it with stuff. So all my stuff is going to be $2 for every topping. So if I get one topping, $2. If I get two toppings, $4. If I get three toppings, $6. But then I also have to get a bowl, otherwise I'm just going to carry a handful of cheese somewhere, and that would be generally kind of messy. I need a bowl. I can't just have a handful of cheese. No, please won't give me just a handful of cheese. They should not give me a handful of cheese. That would be very messy. So we also need to get the bowl, so what are we going to do with the 1? Plus the 1. So a lot of times in these stories, per or for each or for every is going to be kind of a clue word that might be our slope. If it says for each or for every, it's almost always going to be multiplied against something. And most of the time, it's going to be our slope. Like I say every, because there's always an exception, but most of the time, that's our slope. So let's see about the sandwich line, see what we can do for that one. So my sandwiches, we got a plain sandwich is $5, and it's $1 per topping. So how can I figure out how much my sandwich would cost? Our $5. What if I want toppings and stuff? Cheese. And $1 per topping. So how can I put that into my equation? That'll be additional on top of my sandwich. I can't take stuff away from my sandwich. How can I put the $1 per topping? I could do 1 T. Well, you know, cheese, it's $1. Lettuce, it's $1. They're charging me for lettuce. Tomato, $1. Onion, $1. The more things I add, the more it's going to cost. So it's going to cost more if I do it like that. It is 100% okay to write it in this order. We just would need to be careful when you think about something like, graphing, because this one is my M. It would be with my variable here. And this guy's the B. So this one we have them in flip-flopped order, but it's absolutely okay to write our equations in that order because it's 100% the same thing as 1t plus 5. Means the exact same thing. You also don't have to write the 1. I could just put it as a t. Means the exact same thing as if I have 1t. So I just say t. Either way is totally fine. Neither one of them is righter. Neither one of them is better. It just is. Okay? Questions on this bit? Because what we're going to do for the rest of this chapter is we're going to start working with more than one equation at the same time. So we're going to work with something called a system of equations, meaning we're going to look at 2 to start with at the same time. But The first way we're going to look at them requires us to remember something, so we're going to remember. On page 8, how to graph lines. I know we've done it. Last chapter, we did some line graphing. We got pretty good at them. But just as a real quick refresh, at the bottom of page 8 in our notes, we're going to practice doing 2 lines, one of them in slope-intercept form, one of them in that standard form. We could also use point-slope form, but we don't need to. So at the bottom of page 8, we have these 2 equations. Number 1 is in our slope-intercept form, that y equals mx plus b situation, and then number 2 is in our standard form. So our slope-intercept form, this guy, we can just straight up graph from it. We don't have to do any calculation. We just kind of need to play match them up to figure out the pieces. So for this first one, when we're in slope-intercept form, where do I start? Where am I going to put my first point here? 5. This b, this 5, is our y-intercept. This is called slope-intercept because this first point, this m, that's our slope. And the b, that's our y-intercept. So we're going to start on our y-axis at positive 5. That's my first point. How do I move with a slope of negative 2? Because that's what our slope is here. How do we move with a slope of negative 2? Super close. Not left 2. Down 2, right 1. We're going to go down 2, right 1. Down 2, right 1. The more points we put, the easier it is to connect them up. I will come and sprinkle some rulers around. Because, especially since we're going to start looking at these systems, we really need our lines to actually be, decent lines. Awesome. There we go. All right, so we're connecting our dots up as many as we can to fit on the graph. Go edge to edge on the graph. Don't give me teeny tiny little baby lines all the way from one end of the paper or one end of the grid we give you to the other. Use your ruler. It is important, and yes, I can tell. But it's really important because we're going to be using lines to figure out answers today. So our lines need to actually be straight. So our slope-intercept form, we can just start with our points. Intercepts, move with slope. For the ones that are in standard form like this, we could solve it into slope-intercept form. I could go and get this to be a y equals and do this exactly the same way. 100% valid. I could also do the standard form equations by finding our x and y intercepts. That's kind of what these are set up for us to do. You can do it either way. It genuinely does not matter if you put this into a y equals, so you can do your slope-intercept form, or we find our x and y intercepts. I'm going to do our x and y intercepts up here, just because it's a good thing to remember. Because our x-intercept, that's when I want to know what x is, because I know my y is going to be 0. If I substitute in 0 for y, we're going to get 4x plus 0 equals 20. Because if I put a 0 in right here, 5 times 0 is 0, that part goes away. We just get the 4x equals 20. So my x-intercept is going to happen at 20 divided by 4 which is 5. So my x-intercept is at the point 5, 0. So that means my x-intercept is right here. Then we can do the same thing for that y-intercept. My y-intercept, this time it's not that I know my y is 0, because I know that my x is going to be 0. That's the definition of my y-intercept. So my y-axis, x is 0. If x is 0, 4 times x is 0. And we just look at the 5y equals 20. So 5y equals 20. So here my y would be 20 divided by 5, which is a positive 4. So my y-intercept is at the point 0, 4. 0, 4. So if you do it with your x and y-intercepts, it takes 2 separate points. If you solve this into slope-intercept form, that'll do the same thing. You just need to do something because we cannot freehand it from standard form. Remember to use your ruler, go through your points, like that. And again, you could solve this into slope-intercept form. I could subtract 4x from both sides and then divide everybody by 5. Totally fine, absolutely works. Just wanted us to practice in a couple of different ways. Questions on the remembering about graphing stuff? Because what we're going to do when we're starting to work with systems is we're going to do 2 equations on the same graph. So we're going to graph 2 lines on the same graph, and we're going to be looking at where they cross. That's the piece we're trying to figure out when we're looking at 2 equations at more than one time. We're going to get pieces that look like this. So on page 9, you have this picture. These are the kind of options we're going to get when we graph 2 lines at the same time. I could have 2 different lines that cross somewhere. I could have 2 parallel lines. On this one, they did actually put 2 lines. It's just that they're stacked right on top of each other. So it wound up with 2 equations that gave us the exact same line. So when we have 2 lines that kind of crisscross, this has a solution right here. I'm going to get brighter colors. Right here. Our solution is going to be the point where they cross. We're going to have one point, and it's going to be an ordered pair. We have to have both x and y. So if we have a set of lines that cross, we're going to have one solution. And when we're solving it with equations, we're going to get y equals some number and x equals some number, so that our answer will be an ordered pair. And yes, you have to have both pieces, the x and the y. Don't just tell me the solution is when x equals 3. 3 what? On this middle one here, again, it's that they've graphed 2 lines for us. So they have this blue line or this purple line here, and then they're also going to have another line right on top of it. Let me put a white one here. Like that. So they're stacked on top of each other. So if we're thinking about 2 lines that are stacked directly on top of each other, and we're looking for a solution where they cross, these cross everywhere. They're stacked right on top of each other. They're the same line. So the way we word this and what we call this is saying that we have an infinite amount of solutions, or infinitely many. We have an infinite number of solutions because they're crossing everywhere. If they're stacked right on top of each other, they're crossing here and 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 everywhere in between. They're crossing everywhere, and they keep going further and further out. When we get into solving this with equations, what this is going to look like is my x's and y's are actually going to cancel out, and we're going to wind up with no variables. And we're going to get something that's inherently true, like 3 equals 3. 7 equals 7. 0 equals 0. But we'll have no letters left. I can get all my letters to cancel out. So we'll get something inherently true. When we have something like this third one, our parallel lines, do those ever cross? No. That is kind of like the definition of parallel lines, is they're never crossing. So if we're looking at intersections here, that's not going to happen. This is when we're going to have no solution. So no solution means they're never, ever, ever going to cross. And when we're working with our equations and we're trying to look at these pieces without having to do the graph, we're going to have all of our letters cancel out. And then we're going to get something inherently false, like 0 equals 5. Or 7 equals -3. That is just inherently false. 0 does not, in fact, equal 5. 7 does not equal -3. -27 does not equal +27. -2 does not equal +2. So if we get something true, we have an infinite number of solutions because it's essentially the same line. If we have parallel lines, we have no solution. And we'll look more at what I mean by these kind of bottom things when we start looking at the equations to do these without graphing. Today we're going to find solutions by graphing. So, questions on these bits? I know we're not entirely sure what I mean by these parts, but we'll look at those, I promise, over the next couple of days. Okay. So this first system that they've given us down at the very bottom of page 9, they actually did the graph for us. Yay! This is also part of the reason why we don't typically use the workbooks, because that's how they did all the graphs. Yay! So if we're trying to solve this system of equations, what they've done is they have graphed both of these lines. They have this line, that's this guy down here. This one is the kind of slopey line, this line here. And this line is the very, very steep line, this guy. So they've graphed both lines here, and all we have to do is figure out where our solution is. Where is our solution on this? I heard a bit of it, so it's here. We're counting 1, 2, because we're looking at this guy right up here. That's where my solution is. So we just need to name this point. We need to give its address. Our solution is going to happen at the point 2, comma. That's not allowed to see, but then we have 1, 2, 3, 4, 5, 6, 7. 7. 2, 7. So I can't just say x equals 2. I can't just say y equals 7. I need the point 2, 7. The whole point. Every time we're working with a system of equation, I need both the x and the y. If you just find x, you're not done. If you just find y, you're not done. The whole point. Okay? So our solution is the whole point, but we're going to find them by graphing. So we're looking for the point. We have to make the graph. Okay. Let's do this whole thing. Next page, we have 4 graphs on here. We'll see how many we get there. We are going to try and solve these by graphing. We want to find the point where they cross. So we're given 2 lines here. These ones are both in slope-intercept form. So we can do our graphing kind of however we want. I'm going to use purple for the top line, and I'll use green for the bottom one, just so we can kind of keep stuff clear. I try and keep things color-coded so it's easy to figure out. So for this top line, what am I going to do first? Where am I going to put my first point? Y equals 5x plus 2. Starting at a positive 2. My y-axis positive 2. How do I move with a slope of 5? Up 5 over 1. So 1, 2, 3, 4, 5 over 1. 1, 2, 3. Oh, I run out of spaces going up. I could also go down and to the left. If I want to go up and right, I could go down and left. It's going to be on the same line. So down 1, 2, 3, 4, 5, left 1. Sometimes, especially if you start running out of spaces, it's easier to go the other direction. Down 5, left 1. Because the more points you have, the easier it is to connect them up. If you just have 2 points and they're very close together, your line is probably going to be a little bit wonky. So when I connect this up, I need to change my line weight. That was very... My line should look something like this. So there's our first line. Make sure you use your ruler, because remember, we're looking for the place where the lines cross, which means we need to see where they cross. Use a ruler. It's going to matter. Because if I draw my line and it goes like that, my points are going to be in the wrong spot. Make sure you're using a ruler. And then very similar vibe on the next one, on this green one. Where's my first point going to be for my green line for the y equals minus x minus 4? My first point's going to be at that negative 4. That's my y-intercept. That's this guy right here. And then how do I find my next point? Down 1, right 1. We're going to go down 1, right 1. Down 1, right 1. And again, the more dots you have, the easier it is to connect them up. Or I could go, instead of down 1, right 1, I could go up 1, left 1, up 1, left 1, and fill it in that way. The more points you have, the easier it is to get an actually straight line. Because it should look something like that. Graphing the lines does not count as solving it. For the solution, I need a point. Where is our solution? It's this guy right here. This is our solution right in here. And that's going to be at the point negative 1, negative 3. So I made my dot very, very chunky, and my lines are very, very thick, so sometimes they're covering the numbers. But I can see it's down 3 spots here, left 1 spot, negative 1, negative 3, as an ordered pair in the parentheses. Questions on this one? Okay, then let's take a look at the next one. Let's look at number 2. So here we have one in slope-intercept form, but then we have one in our standard form. So we're going to have to actually do a little bit of math on this one. You can either, again, make this one be slope-intercept form. We could do it with our x and y intercepts. We could do this in any number of ways. I tend to kind of just go with my x and y intercepts when it's in standard form, but if you want to solve it into slope-intercept form, that's totally valid. So let's take a look and see what's going on here. So again, I'll do the top one in purple. I'll do the bottom one in green. They just have a pretty decent contrast and they both show up pretty good on the screen. And it doesn't matter what order we graph them in. I do know that my bottom one's in slope-intercept form, so sometimes we like to do those first because they're nice and easy peasy. So I'm going to put that green one up first. My y equals 1/2 x plus 3. So we're going to start where? On the green one? Where do I start? The 3. Positive 3. And then we have our slope of 1/2. So that means I'm going to do my rise and overrun. So my rise of 1, my run of 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. This kind of a... Or I could go down 1, left 2. Down 1, left 2. It does not matter which direction we go as long as we are careful about which tool we use for it. So our line should look like this. So that's our green line. For the purple one, again, you could switch this around into slope-intercept form. We could find our x and y intercepts. If I want to find my x and y intercepts for that purple line, my x-intercept happens when y is 0. So that means we're thinking about when x plus 2 times 0 equals 2. Or that's just x equals 2. Because if I know my y is 0, I know 2 times 0 is 0. So we're just looking at the x and equals 2. So my x-intercept happens at 2, 0. So that one I didn't even have to do very much math to think about it. And then our y-intercept, we would find out a very similar way. I know my y-intercept happens when x is 0. We just got to figure out what y is. So if I know that x is 0, when I substitute that in, this thing is 0 plus 2y. So I'm just thinking about that 2y equals 2. So the x and y intercepts doesn't take a ton of math, and a lot of it we can do in our heads, but it is just a slightly different process. Because where is my y-intercept going to be? When does 2y equal 2? When y equals what? What do I do here? Divide by 2. And 2 divided by 2 gives me 1. So my y-intercept is going to happen at 0, 1. So I've got 2 little points here. Now they are pretty darn close together. So we just need to be really, really careful, because our line needs to go through those 2 points, but it also needs to go about as far as we can. So our purple line is going to look kind of like this. So where is our solution on this one? -2, 2. Right here. This is the spot we're looking at, where they cross. So our ordered pair here, our x is -2, our y is +2. So we've got to get the ordered pair, the x then y, and they have to be in that order. It's alphabetical order. That helps us remember what order they go in. They have to be in that order. We have to have those pieces in that order. Okay, questions on this one? Let's take a look at number 3. Again, some very similar pieces here. I'll do this one in green. I'll do this one in purple. I just like to keep things clear. So again, we have our green one's in our slope-intercept form. We can do this. We start at our 4, because that's our b, is that +4. And we're going to move with our slope of a +2. +2, that's our rise of 2 and our run of 1. I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, like that. I'll do it green. Or I could go and switch both of them. I could go down 2 and left 1. As long as I switch both, it still counts as a positive slope. Down 2 and left 1. The more dots we put, the easier it is to connect them up. We need our lines to be accurate. Since we're trying to read the points off of them, we do need our lines to be pretty decent. So make sure you're using that ruler. Really important. That's why I'm not freehanding these on the screen. I'm using the digital ruler, also known as a line tool. And then for the purple one, again, I could solve this in a slope-intercept form. I am going to go ahead and just do this with my x and y intercepts. So again, my x-intercept is going to happen when my y is 0. So if I substitute in 0 for y, I know it's going to be 2 times 0. So this whole chunk is going to be 0. So this whole piece is going to disappear. So we're just looking at when does 4x equal 2. If you want to write the whole thing down where you substitute your 0 in for y and put it as 4x minus 2 times 0 equals 2. And then 4x minus 0 equals 2. And then 4x equals 2. Totally valid. To get my x by itself, I need to divide both sides by 4. And we're going to get that x equals 2 over 4. Or that's the same thing as 1/2. Or 0.5 if you put it in the calculator. Any of them are totally fine. So we're going to need to be careful because my x-intercept is not exactly on a point. It's in a halfway. It's in between. Ew. Unpleasant. And then we'll do the same thing with our y's. To find our y-intercept, our y-intercept happens when x is 0. Y can be whatever the heck it wants to be, but I know my x is 0. Oop. So if I put 0 in place of the y, in place of the x, because I already did the y, that means my 4 times 0 is going to be 0, so we get 0 minus 2y, also known as negative 2y, equals our 2. So we can find our x and y intercepts. Here our y is going to actually equal, when I divide both sides by negative 2, our y is going to equal negative 1. We're going to wind up with this point right here. And if we are super duper and careful when we put these together, even though we only have 2 points here, we do need to make sure we get this line across the whole graph. So just be really careful, because where do they cross? They don't. So what's our solution? There is no solution. These do not cross. If we did solve this into our slope-intercept form, what we would wind up with is the exact same slope and a different y-intercept. So if they have the exact same slope and different y-intercepts, they are going to be parallel lines. That is the definition of parallel lines, is the exact same slope and different intercepts. So if we get 2 parallel lines, that's what it means. No solution. They don't cross. They are railroad tracks. Train tracks don't go and have the wheels touch each other. That would not be good for the train. All right, let's do one more. This will be our last one. And again, we've got a slope-intercept form and a standard form. We can do this whichever way we want. I'm going to keep doing it with my standard form being in 2 x and y intercepts because it's good practice. Because we can graph things in either way. Again, I'll do this top one in purple, and I'll do the bottom one in green. And so this time it's my purple one that is in my slope-intercept form. So we've got our minus 1/2 x plus 3. So we're starting at that positive 3 for my y-intercept. And moving with our slope of negative 1/2. That's when I'm going to take my rise over run, and I'm going to flip one of them. So I'm either going to go down 1 and right 2 to get to my next point. Down 1 and right 2. That is an absolutely valid way to get to those points. Or I could go up 1 and left 2. It does not matter which direction I switch. Negative slopes are always going to kind of look like a slide. Positive slopes are always going to look like you're climbing a mountain. So if it looks like a slide, if it's going down, yelling timber. If it's going down, negative slope. If it is climbing, then it's positive slope. So this is our purple line. Then to get our green line here, I'm going to do my x and y intercepts again. So if I do my x-intercept, that's going to happen when my y is 0. And we're going to have that 2x equals our minus 3. So our x equals, a fraction, minus 3/2. Unpleasant. When you have things like improper fractions where the bigger number's on the top, switch them to either to mixed numbers or to decimals. This is minus 1.5. That is much easier for us to, graph than negative 3/2. Ew. Negative 1.5, that's a lot easier to spot because our x being negative 1.5 is going to be somewhere right around here when y is 0. And then our y-intercept we'll get from taking our x as 0. And then we can find our y. Well, if x is 0, 2 times 0 is 0, we get minus y equals minus 3. So that's when we divide both sides by negative 1. Divide both sides by negative 1, and we're going to get that our y equals 3. Y equals 3 is going to be right here. So even without connecting them up, I can see my point where they're going to cross, because the whole point is trying to figure out where these lines cross. 2 lines together, figuring out where they cross. So where is our solution on this one? 0, 3. It is the point where they cross. And in fact, it actually ends up being this y-intercept right there. Again, you don't have to do your standard form in x and y intercepts. It's just kind of set up that way. Okay. Questions on these ones? That's all of it. I'm going to pass out homework 4, which is just these kind of graphing systems. Tomorrow we're going to look at how to do these with the equations, and we're going to do that for a couple of days. So, like, you guys can do absolutely everything on this homework. I am still going to have it meet for 2 days, so it's not going to be due until Wednesday, just because I don't want you guys to have to, like, speed rush them. So, I'm going to put that out, and then I'm looking at some, oh, I have a question. Okay. Copy. Oh my gosh, this one. What's that?
Can I get a pass for kids so I can like try to get rid of this?
For when? I'm leaving for Wednesdays. I'm after school today until 3:30, but I'm only open in 5th period on Wednesdays.